Like to know about electricity and magnetism? This is a 150 years old study. Why we learn it nowadays, whereas artificial intelligence changed the whole world. But every day we use lots of devices that depends upon power system. That means our all electrical devices is based on electricity and magnetism. First field is electric motor, in which coil of wire attached to power supply and coil is able to move within two magnetic poles. Second example is electric generator. Electric current is generated by the help of magnetic field moving in a conductor. And how can we forget about light? One such part of electromagnetic spectrum which is visible by human eye. It's a combination of electrical and magnetic field. Bioelectromagnetism is an area in which we find electric and magnetic phenomena within the living tissues. So, electricity and magnetism is a subject which deals a lot of areas like laser, refrigerator, electrical circuit, and electricity and magnetism is a subject that is very important to know. And this MOOCs has been designed to provide better information to you learners. In this, you are able to see the lectures in the form of video, animation video, and articles. Second one, you get practical demonstration video. Third is your discussion form. Fourth one is to do homework in the form of quiz, puzzles, and assignment. This course is not limited to the formation of electric current by the moving of electrons. It involves the study of vector calculus, that is a combination of vector and calculus. It is no need to be intimidated by the name of vector calculus. Then solve Coulomb's law and electric field theories using calculus of vector approach. Last, electric potential will be covered by using solve theories. It is very exciting journey. So enroll yourself for this course.
Let's start. First part of electricity and magnetism. In this, we cover scalar and vector field and two more operators, del operator and Laplacian operator. Okay, figure show temperature have a variation on earth. So temperature have a value at every point in a space. So many quantities, weight, density are scalar quantity which have value each and every point in a space. So we define a mathematical function for these scalar quantity. That function is known as scalar field. Mathematically, we can write this function f is equal to f r vector, where r vector represent x, y, z coordinate of a space. Similarly, vector quantities like air, gravitation force has continuous and unique value at every point in a space. The mathematical function which represents these vector quantities is known as vector field. Mathematically, we differ it from scalar by adding f vector and direction. Here we represent f vector is equal to f r vector, whereas r again represent x, y, z coordinates of space. Vector quantities we can't see with our own eyes. So I take an example from PHNet software. Here I placed positive charge and equal negative charge. Electric field lines start from positive charge and ends at a negative charge. And we can change its distance between them. Take the value of voltage, values and direction. Now pick a sensor to get the value of voltage. This is an example. It gives the value and degree, direction, voltage changes for negative charge. Now we see the same changes at positive charge. You can also check the variation between these two charges. It's a very wonderful software. With the help of this, we can find voltage at every distance at each and every point in a space. So it's a vector field working example. Difference between scalar and vector field is solved now. Two mathematical operators which solve these field problems are known as del operator and Laplacian operator. Del operator, it is depends upon the coordinate of the system. When it apply on a scalar field, it converts into vector field. Mathematically, we can write del vector is equal to I cap curly by curly x plus j cap curly by curly y plus k cap curly by curly z. Laplacian operator is a scalar product of del operator. Del dot del is equal to del square, and del square is known as Laplacian operator. When it is applied on a scalar field, it gives scalar quantity. When it is applied on a vector field, it gives a vector quantity. In next lecture, we solve gradient of a scalar field, divergence of vector field, and curl of vector field.